Welcome to this M1 MEI Kinematics revision video. We're going to be looking at January 2011 question 1. We're given that an object is moving along a vertical straight line, and we have the velocity time graph part of the motion here. Initially the object is moving upwards with a velocity of 14, and after 10 seconds it's moving downwards with a velocity of 6 meters per second. And we're asked to look at the following things. We're asked to consider the interval 10 to 15 and 15 to 20, where we're given some information about the motion. And the first part asks us to complete the velocity time graph using that information. So we have a full graph for the period 0 to 20. So that's 2 marks. We then have to calculate the acceleration for the first period, 0 to 10, and then calculate the displacement of the object from its starting point at t equals 0 until its finishing point at t equals 20. So let's start to have a look at that. At t equals 10, we can see that from the graph here that we already have a speed or a velocity of -6, and we're told that it's going to have a constant downwards or -6 velocity for the whole of the 10 to 15 second period. So that will be a horizontal straight line here between 10 and 15 at -6. We're then told that the velocity is going to increase uniformly, which means it's going to be a straight line until it has 0 velocity at t equals 20. So from the end of the horizontal line it will increase uniformly in a straight line up to a velocity of 0 when t equals 20. So let's have a look at what that will look like on a graph. And I've done a copy of the graph here. So we're going to have a horizontal line between 10 and 15, and then a uniform straight line up to a velocity of 0 when t equals 20. So that's the first part of the question done. Now we have to calculate the acceleration of this object in the time interval 0 to 20. So we can use the fact that the acceleration is the gradient of a velocity time graph, and so we're going to be looking at the change in velocity divided by the change in time. So let's go back and have a quick look at the graph. The change in velocity, well, we started at 14 and we've gone to -6. And that's happened over a 10-second period. So the difference is -6. Subtract 14, and the time period is 10. So we have -20 divided by 10. So the acceleration is -2. Moving on to the final part of the question, we have to calculate the displacement of the object from t equals 0 to t equals 20. So let's have a think about the graph again. Displacement is given by area underneath the graph, but we need to think about the two parts of the motion separately. In this section here, this triangle, we know that the object was moving upwards. It had a positive velocity, so it's moving upwards. So this triangular area will be a positive displacement, and then this trapezium underneath, that will be a negative displacement because the object was moving downwards. So we're going to have to think of this as a positive and as a negative displacement. So the triangle, which was positive, has an area of half multiplied by the base multiplied by the height. Well, the base, we can see here, is 7 and the vertical height is 14. So that gives us 49, and we need to remember that that is a positive displacement. And then for the trapezium, if we remember the formula for a trapezium, A and B are the parallel sides and H is the perpendicular distance between them. So let's have a quick look at the diagram. The parallel sides, well, the top one, 7 to 20, that's obviously 13, and the bottom one is 5, so 13 add 5. And then the height of the trapezium is 6 because we're at -6. So we had 13 add 5 for the parallel sides, and the distance between them was 6. So if we work that out, that's 54, and that was downwards displacement. And so overall, we had 49 upwards, 54 downwards, and so the overall displacement is -5, or we could say 5 meters downwards. Okay, so let's go back now and see if we can annotate our answer with the marks, how the marks will be allocated. So let's go back to part 1. So in part 1 you got a B mark for each of these 2 sections of the graph being correct, so one for the horizontal and one for the sloping section. When we are on to part 2, again it's 2 marks. You get 1 mark for attempting to work out the change in velocity divided by the change in time for the acceleration, and an accuracy mark for getting that correct. And then in the final part you get 1 method mark for attempting to work out the whole area underneath the graph. You get a B mark, an independent mark for getting 49, another independent mark for getting 54, and then an accuracy mark for correctly combining those to indicate that we have a 5 meter downwards motion. If you'd like to have a look at any of the other revision videos, go to our website at www.furthermaths.org.uk.